Hello class, today we'll be doing section 8.3, equations of lines. So we're going to find an equation of a line using the point-slope form, find an equation of a line using the slope-intercept form. We're going to use the slope-intercept form to sketch the graph of a line from the equation. We're going to find an equation of a line parallel or perpendicular to a given line through a given point. We're going to know how the formulas for Fahrenheit and Celsius temperature scales are derived. So let's start with the point-slope form. The equation of the line through x1, y1 with slope m is written in point-slope form as y minus y1 equals m times x minus x1. So using that equation, let's find the standard form of an equation. The line with slope 1/3 passing through the point -3, 2. Okay, so here we have y minus y1 equals m times x minus x1. What we're going to want to do here is this is your x1, this is your y1. Okay, so we're essentially plugging these points into this point-slope form. Okay, so we have y minus y1, so that's y minus 2. Y minus 2. And then the 1/3 is your slope. That's what m stands for. So we're going to plug in 1/3 there. Then it's x minus x1. That's minus a -3. And we do need to simplify this. Okay? So that's what I'm going to go ahead and do in this next step. I'm going to go y minus 2 equals 1/3 x plus 3. Now it asks for it in standard form, not point-slope form. Okay, so because it asks for it in standard form, we got a little work to do. This is the point-slope form. We want it in standard form. So we've got to convert it from this point-slope form to standard form. So what we're going to do first is try to get rid of this fraction right here. And to do that, we're going to multiply everything by 3. Okay. So I'm going to multiply this whole everything by 3. And that's where we get the 3y minus 6. The 1/3 goes away over here and just leaves you with the x plus 3. Now we're not done yet. We still have to put it in standard form, which means that we need to get the x and y on the left-hand side and then the regular numbers on the right-hand side. So I'm going to start by adding 6 to the right-hand side. That's going to give me 3y equals x plus, plus 6 plus 3. And that's going to give me 3y equals x plus 9. Ooh, there it goes. All right. Now, the next thing that I have to do is I have to get this x over here to the left-hand side. So I'm going to subtract it over. That's going to give me the -x plus 3y equals 9. Now you notice that isn't the same thing that they have here because we want that number in front of the x to be positive. In order to get it to be positive, I have to basically multiply the entire thing here by -1. When I do that, the x turns positive. I get a -3y, and then the 9 turns negative. Okay, so we have it in our standard form here. X minus 3y equals -9. Now, let's find the standard form of an equation of the line passing through the points 2, 1, and -1, 3. Okay, the first thing we need to do is find the slope. Okay, so if this is x1, y1, and this is x2, y2, we use our slope formula. Okay, which is y2 minus y1, so 3 minus 1 is 2, and then x2, which is -1, minus x1, which is -2, gives me a 3 here, or a -3. So we get a -2/3 for the slope. Once we have the slope, we can use either point to put it into point-slope form. Okay, in this case, it looks like we are using the very first point. Okay, so we're going to do y minus y1, which is 1, equals the slope, which we found to be negative 2/3, times x minus x1, which is 2. Okay. Like I said, we want to put it in standard form. And if we're going from point slope form to standard form, then we're going to have to multiply to get rid of, this fraction. Okay, so we're going to multiply the entire thing by 3, right? That's going to give us 3y minus 3 equals negative 2 times x minus 2. Okay, I'm going to simplify this a little bit to be negative 2x plus 4. I'm going to add the 2x to the left-hand side, get 3y plus 2x minus 3 equals 4. I'm going to add the 3 over. That's where the 7 comes from. Running out of space here a little bit. I do want to order it appropriately with the x first. And that's where we get the 2x plus 3y equals 7, being our standard form. Alright, now let's go on to slope-intercept form. The equation of the line with slope m and y-intercept 0, b is written in slope-intercept form as y equals mx plus b, where m is your slope, b is your y-intercept. Okay, let's graph the line with the equation y equals 3/2 x minus 2. Alright, now that minus 2 part here, that is your b, which is your y-intercept. That means that's where it hits the y-axis, which is right down here. Okay, and then it has a slope of 3/2, which means we're going to rise 3, 1, 2, 3, and we're going to run 2 to the right. All right, and then I can put that other point, connect those two lines, and with the slope-intercept form, it's that quick and easy to have your graph done. So let's look at a summary of the forms of the linear equations here. Ax plus by equals c is your standard form. X equals a is a vertical line. Y equals b is a horizontal line. Y equals mx plus b is your slope-intercept form. Y minus y1 equals m times x minus x1 is your point slope form. So we've got quite a few forms here to keep track of. All right, let's try this one. It says use the slope relationship. Okay, talking about perpendicular lines. It says find the slope-intercept form of the equation of the line perpendicular to the graph of 2x plus 3y equals 6. Now, key points here. Perpendicular. That means we're looking for the negative reciprocal of our original slope. Now, we don't have our original slope, okay? So what we're going to have to do is take this original equation, solve for y, so that we can find our original slope. So the first thing I'm going to do is subtract 2x over. I'm going to have 3y equals negative 2x plus 6. Then to get y by itself, I'm going to divide by 3. So I'm going to get y equals negative 2/3 x plus 2, which means my original slope here is negative 2/3. But I need the negative reciprocal of that, which means I need to flip it and I need to make it negative. Now what we notice is it already was negative, so if I double negative it, it just makes it into a positive. So I have the slope of this new perpendicular line that I need, but I also have the point of it, okay? So we're going to use the point negative 4, 5 that was originally given to us, along with this slope that we found that negative reciprocal of, in order to basically find this new parallel or perpendicular line. Now we can use the point slope formula because this is x1, y1, and we can plug in what we have with the slope and that point. So we have y minus y1 equals the slope times x minus x1, which is negative 4. Okay, then all we have to do is do some simplification here. Minus a -4 is a +4, so that simplifies. Now, we can also distribute this 3/2 here to this right-hand side, and I can get y minus 5 equals 3/2 x plus 6, because 3 times 4 is 12, and 12 divided by 2 is 6. Okay. Now, if I want to get it in slope-intercept form, which is what we're kind of going for here, then I'm going to add 5 over to the other side. 6 plus 5 is 11. So in slope-intercept form, this perpendicular line is going to be y equals 3/2 x plus 11. All right, let's try this example. It says deriving the formula for converting Celsius to Fahrenheit. In the Fahrenheit scale, water freezes at 32 degrees and boils at 212 degrees. If in the Celsius scale, water freezes at 0 degrees and boils at 100 degrees. Use this information to derive the formula for converting Celsius to Fahrenheit. Well, all that information is right there is a set of 2 points, right? So 2 points, 0 and 32, corresponding to the water freezing point, and 100 and 212 corresponding to the water boiling points. Okay, if we have 2 points, we can create a line, which means we can also create the function of that line. Okay, so let's start with the slope. So if I go back here, this will be our x1, this will be our y1, this will be our x2, this will be our y2. Okay, easy enough. So we're looking at 212 minus 32 over 100 minus 0. So we've got essentially 180 over 100, or if I reduce it to lowest terms, 9/5 for our slope. Okay, once we have the slope, we can now substitute the y-intercept into the slope-intercept form to find the equation of the line. You're like, okay, you kind of took me for a jump there. I know the slope, we found it, but how do I know the y-intercept? Well, the y-intercept is where x is 0, and we already have that. 0, 32. So essentially, they gave you the y-intercept point without you even realizing it. So because I have that y-intercept form there, I'm able to just plug in the 9/5 for the slope, which is your m, and the y-intercept point, which is 32, which they inadvertently gave you to begin with, and now I have proven and shown the conversion formula for Fahrenheit and Celsius, or Celsius to Fahrenheit. So all I have to do now, if I want to be really precise about it, is replace the x with C, because it stands for Celsius, and the y with F, as it stands for Fahrenheit, and I now have the Fahrenheit and Celsius formula here, where I'm converting from Celsius to Fahrenheit. F equals 9/5 C plus 32. Now that completes this lecture. If you have any questions, don't hesitate to reach out to me by email. Otherwise, I will see you next lecture.